Okay, welcome everyone to our March 2026 Airflow Town Hall. Can't believe we've been doing these for a couple years now, and I'm grateful for all of our returning listeners and all of our new folks who are here as well. So thank you all for joining so much. Today we have a really interesting agenda. Vikram is going to give us our project update this month, and then David Blaine is going to go into a presentation he actually gave at our Stuttgart Airflow meetup recently that Jens on this call helped put together. So thank you, Jens. Thank you, David, for making that meetup happen in Stuttgart. And we're excited to hear what David has to say. And then we're going to hear from a PR of the Month winner, Christos Bisias, on his PR. And then I'll give you a quick community update. Spoiler alert, it's going to be about Airflow Summit. Spoiler alert, the CFP closes March 13th. So if you have not submitted a talk to Airflow Summit, you still have time, but make sure you do it ASAP. And if you need any help on it, send me a note. I'm happy to kind of walk you through what it looks like. I'm happy to have our team give you feedback on your CFP submission. So send that my way. And then we'll close out, hopefully on time. If this is your first time joining this call, couple reminders. We don't make decisions on these calls. That's reserved for the dev list. So if a conversation happens in the chat and you want to bring it to the wider community, you will then need to take it to the dev list. Obviously, this is open for everyone to attend. This is an open source community. It's what we love about it. And these sessions are always recorded and they are posted to the Apache Airflow YouTube channel. I get a question about this every single town hall. They're always recorded. They're always on the YouTube channel. So make sure you look for them there. And I also make sure to share them in the town hall channel in Airflow Slack, as well as to the dev list. So you can look for them there as well if you don't want to go directly search on YouTube. Okay, and with that, I will pass it off to Vikram to give us our monthly project update. Vikram, do you want me to drive or would you prefer to?
You can drive, Brianna.
Sounds good.
Hey everyone, I'm Vikram Koka, and I think I know almost everybody on the call. So been working on Airflow for about 7 years now. Been a committer for a while, and like been on the PMC for a while now as well. And really excited to share with you all the details of, or some of the details of everything that's going on. Covering all the details would take a heck of a lot longer than I have the time available today. But at a broad stream of work standpoint, there's so many things going on that I'd really had to kind of select what we would actually talk about today. So here are four streams of work, which I feel personally very thrilled about everything kind of going on with the community. And the first thing is really on the community engagement. We're going to touch on a lot of non-feature improvements, which have been ongoing for several months, but a lot of which have culminated over the last month or so. And then we actually are getting into something which I'm actually absolutely thrilled about. I'm going to spend the bulk of the time talking about some of our provider work and specifically providers integrations. And then finally closing out with work on the Airflow 3.2 release. And then part of the reason for these the sequence here is so that we can hand it off really well over to David because he's contributing a key element of what's going to come into Airflow 3.2. So with that, if you could hit the next slide, please, Brianna, we'll start with the community engagement. The first thing I'm thrilled to say is thanks to all of you and so many people who are not on the call today, the community contributions continue to be very, very high. And just over the last 30 days, some quick metrics is there's about 200 people who have contributed to the Airflow project. There's about 300 active issues, 385 active issues over this period of time. Total commits were, I think, about definitely over 1,000, but 635 commits remain, 156, 1,156 total PRs. Just as context for 3.2, when we look at it, i.e., when we look at like, hey, were all the commits kind of getting in, taking out dev environment or CI commits, and just focusing on the main feature commits, which are actually or changes to code. There was like about 1,500 commits, which were actually going to be part of 3.2. So even though it's a minor feature release from a semantic versioning standpoint, it's actually got a lot of stuff kind of baked into it, whether it is in core Airflow or into providers and integrations or something else. So very, very excited. And thank you so much to everybody for their contributions as part of the project. This is actually what keeps the project going. So really thrilled to see all these contributions. One of the things which I'm really excited by is, and if you could hit the next slide, please, Brianna, is I'd like to recognize the contributions of key people. And I'm delighted to see that Pavan is actually on the call here. And so delighted to say that Pavan has been is now been invited to join the project management committee of Airflow, and we're thrilled to be able to recognize his contributions and everything that he's been doing with the project. So welcome, Pavan, to being on the PMC of Airflow. And I know that you didn't know that the slide was here, but and you're here today, so thank you so much, and thrilled to have you on the PMC.
Thank you, Vikram. Thanks for the community support and all the PMC and whole community. Yeah, thank you.
Awesome.
I'm planning to write a blog post. It will come soon. How my journey started. It will come out soon. Thank you. Yeah.
Awesome. It is, I won't embarrass Pavan any further, so if you want to hit the next slide, please, Brianna. So this is actually one of my favorite parts of really what we've been working on, and like, kudos to so many of the people who actually been leading this and working this. Is like actually the non-functional improvements, which are like, not new features, but like, stabilizing, fixing a lot of the issues which have been reported as part of 3.0 adoption. There's been a huge amount of work which has happened over the last 4 months, roughly, if not longer, about 4 months, I actually think. Started in November, and I think it's like, over the last 4 months, there's been a bunch of work led by Rahul and other people on the UI test framework, which has been created. A lot of like, test cases actually populated. I think over 121 test cases created, stuff like which is an end-to-end test framework, and then like other things actually getting moved over to the individual like, UI specific unit tests because the overall CI/CD was taking too long. I'm really excited by the things which it has actually caught over this period of time. So I'm very happy about that. The second piece is we had really done a huge amount of work as part of 3.0 around the task SDK separation, and also very thrilled to say that the IP72 now is complete with about over 300 PRs merged. Amog reported this in the last dev call. And when I look at the project board now, that it is complete. And so really thrilled that the vast majority of the stuff or like all the originally identified scope is now done. I love the fact that we can close off AIPs and be able to move on. There's been a huge amount of changes of improvements to the UI and to the API server work over the last few months as well. And like, kudos to Pierre for leading this effort, and so many people who have contributed to this. I actually think some of them are on the call today as well. And I mean, just to work on like, just the memory management, resolving all the N+1 query issues, which has taken a lot of time to get done. I think it was the grid view, which actually got completely redone. I could be mixing them up between the grid and the graph view for performance benefits. So I'm really thrilled by all this work, which has actually been done over the last several months towards making this much, much stronger, much easier to adopt. And fixing all the issues which have been reported over this period of time. I don't know exactly how many PRs, but I think this was actually a fairly high number. And this, I just remembered to ask Pierre about this, but there's a huge amount of work on resolving all the open items and like, making this very, very solid. A lot of these have actually been released, I think, as part of the 3.1.x patch releases. So it has been stuff in flight, but I thought it was important to recognize all this work which had been done towards like, making the swim lane stuff very, very solid and resolving all the issues which people had kind of said, hey, this can be better, this can be better, and stuff like that over this period of time. So huge kudos to the team who's actually been working on this very quietly and steadfastly and consistently over the last 4 months. So thank you all very, very much on that front. If you could hit the next slide, please, Bree. So this is one of my favorite things. Now I said I've got a few of my favorite things, but the as following up from AIP 95 of like the updated stewardship model for providers being able to accept new providers, have people contribute and take responsibility for the new providers is a new Airflow registry, and Kakshal has done a huge amount of work on this. I think this is like effectively in preview mode right now, and just love the UI on this, being able to kind of browse all the different providers, and these have actually been consistently getting added. And it is thrilled to kind of say there's about 97 providers, well over 1,500 modules, i.e. sensors, hooks, operators in here, using a huge amount of downloads. It's so much easier to kind of navigate this and actually try this out. I can't wait for this to kind of actually show up in full-fledged form and be able to navigate this and use this. I think it's a huge jump forward. So definitely encourage people to kind of give feedback, and I'm really looking forward to this getting live in the next few weeks. So kudos to Kakshan on this, and jumping from this is a great segue into the next slide, please, Brianna, is the work on AIP 99. Again, Pawan is somebody who originally proposed this. And this is actually a screenshot which I took from, I think, the PR itself, which is, or at least one of the key PRs on this, is the part of the reason I'm so excited by this is building on this huge amount of hooks, which we already have talked about in the prior slide, and new hooks coming on for Informatica and other things, being able to make them a hell of a lot easier to use so that this becomes an agentic workflow and Airflow becomes a way to kind of be able to access this very, very easily. And so all of these hooks are now getting exposed as through Pydantic AI, as like you can start basically building like your code directly to use this as if it were like an MCP. But even though a typical MCP is got a like double-digit number of tools and stuff like that, Airflow's hooks cover literally well over hundreds of methods, and these are all pre-authenticated within Airflow connections. So it really becomes a much greater foundation to be able to do to involve and invoke these. And if you could hit the next slide, please. I would definitely say one of the key, again, this is from the PR, and I didn't expect Pawan to be here. So it's like, Pawan, please feel free to chime in at any time on this front. The beautiful thing when Pawan demonstrated this to me, even on, I think like a month ago, 6 weeks ago, in one of the dev calls, was being able to actually write a prompt. In this case, like, hey, there's a prompt which says, show me the customers who spent the top five total spend, and that's like a regular AI prompt, but it is going to use the SQL hook, connect to the DB API, connect to the database you've actually connected to, and be able to bring the data back automatically, which is fantastic to be able to see. And so this code is like literally a screenshot from one of the PRs in this particular aspect. And if you hit the next slide, please, Brianna, you can actually see the result of the now. I probably should have made this significantly larger from a font standpoint, but you can actually see the top five customers. You can see this actually running and be able to see this directly within the Airflow logs, or like this is actually what you'd see as part of a DAG. So the evolution of Airflow and all the integrations to be able to be used in an AI model directly and through this layer is really kind of exposing a much higher level of abstraction, and much easier to do as well. Right now, I'm not saying by any means I don't want to oversell the work, which Pawan and Kakshal and others have actually been doing on this. It is not the end, but it is a great foundational beginning as the next level of abstraction. And as an old software engineer, I love higher levels of abstraction because you don't need people to kind of worry about the details. And this is the next higher level of abstraction, using Airflow to be able to leverage the agentic models and like, very simple English towards being able to get data from all the different sources and be able to incorporate it in the system going forward. So really thrilled by all the work here being done by Pawan and Kaxel and others. And I would definitely, I just put the PR number here. So people here, please do take a look at it. I know that this is in flight. I'm expecting this to happen over the next little bit, roughly around the same time frame as 3.2. So please feel free to share. Um, on how we actually your feedback and how we can make this better kind of moving forward, so on and so forth, right? So next
Just
slide.
to add that, Vikram, on top of that, what Vikram said, like we have released a couple of operators which works on core like LLM operators or like agentic operator, which basically it knows all the hooks which are part of the Airflow ecosystem. You just need to send the connection IDs and tell what you need to be, and that let the agent operator does internally, like connecting to database. Let's say you have files stored in S3, then the agent can connect to S3 and fetches the data for you and shows. Like it's all baked into this common AI dot provider. And yeah, I mean, there is a human in the loop also integrated. The PR is landed today itself, like where you no need of like a different operator to approve the inside itself, like LLM operator itself as human in the loop. You can like review and proceed. There is no feedback loop. Right now, we are working on that, which will come when the feedback loop comes. What it does is basically you can interactively modify the output and send it back to the agent, and the agent returns back the new output, whatever you requested.
Awesome.
Yeah.
Thanks for chiming in, Paman. So I know Bree said I've got a little bit extra, so I'm like kind of going to 20 minutes, but I'll try to keep it within that, Bree. So Airflow 3.2 is actually coming soon. Really excited by all the work in this front. I want to actually go through all the details. The release branches have been cut. The first beta was cut, I think, earlier this week, and we're hoping for a release candidate in the next few weeks. And if you could hit the next slide. The key elements in the scope for this is like in addition to all the non-functional work we've actually talked about, there's a key element of significant functional work, which is also happening as part of 3.2. AIP 76 with asset partitions. The first part of it is has landed into main, will be released as part of 3.2. This is support for partitions based on dates, right? There are two kinds of partitions which were defined as AIP 76. The first one was date-based partitions, which is what is landing as part of 3.2. The second set is segment or key-based partitions, which are for non-dates, for other kind of elements on which you want a partition based on. That is going to be in 3.3. But the 3.2 level stuff has date-based partitions. It uses a timetable and elements like that. So really looking forward to seeing that ship as part of 3.2. Deadline alerts, the second part of deadline alerts, which is the sync-based callback support, is landing as part of 3.2. The async incarnation of this was part of 3.1. So this is the second part of deadline alerts, which is landing as part of 3.2 and will ship as part of it. The first part of multi-team deployments, this is actually a fairly big AIP as well. The initial experimental support will land as part of 3.2. The layer parts of it will land as part of 3.3, as again, as basically being a follow-on release on this front. And one of the things which is actually very exciting to see is the support for async operators, or like rather async support within the Python operator, which is hugely beneficial for especially file transfer and like lots of little data files or lots of little API calls, and which is landing. David Blaine has been the one who's actually contributed that. So, and he's going to be talking about it in just a little bit. So with that, I'll hand it off to David. Thank you all. Again, happy to take any questions, async or live as well.
Yeah, absolutely. If anyone has any questions or Vikram, please feel free to drop them in the chat as we start our next presentation. And David Blaine, if you'd like to take it away from here, would you like me to drive or would you prefer?
If you want to do it, yes, I will then ask you kindly to switch to the next slide.
Absolutely.
All right. Thank you. So yes, today I'm going to present you the AP98, which allows you to run async codes natively in Python operators. So the first slide is quite important because you could question yourself, why async operators instead of deferrable operators? Already had a discussion at the Airflow Summit last year with different people. And they are also always had the same remark that indeed it doesn't make sense to execute async code in a worker, because even if your code is async, you're still blocking the worker. So actually it doesn't make sense. And we have triggers for that. So yes, I agree, it doesn't make sense. But then my question to you is, why would you need async operators? Because there could be some small reasons why you would add support for it. So for example, to make it easy to use in an operator. But there's one that is very important, and that is when you want to do multiplexing. So indeed, deferrable operators work very great with triggers. And also put a quote here on the first slide. Triggers are great at waiting, but terrible at processing. And that's regarding to the multiplexing. So now if you go to the next slide, I will explain why. So why? So not why, but when does deferrable break down? So first of all, you have to know when you use a deferred operator that there is a lot of context switching behind the scenes. You don't see it, but it's happening. And that part will be partly solved with a pull request I'm also working on that will re-enable the start from trigger that was introduced in Airflow 3.0. So that will be partly solved, but not completely. And then also you have to take into account, as there is already a lot of context switching, if you have like an operator that does paginated calls, you will do it for each paginated call. So that will be even more context switching. Another reason is that triggers also can only yield one event at a time, but that won't be an issue anymore once AP88 will be done. What you also have to take into account is that triggers store their event directly into the database. You don't have, like with operators, an XCOM backend which you can customize. So there you are fully dependent on the database. Also, what you have to take into account with deferred operators, as they rely on triggers, is that triggers must be serializable and static, which means that you cannot execute dynamic code like callabus or lambdas. Everything has to be static. And then another more small issue, it's not an issue, but that you could see as a constraint, is that specialized operators don't offer the same flexibility as the Python operators with hooks, because you rely on the functionality that they expose. So if you need something specific that the operator doesn't do, but for example, you can do it with the hook that it uses underneath, then you're a bit limited. So that's why the Python operator is more flexible. And then also the last part, and that's regarding to the multiplexing, is that dynamic task mapping can, in that case, generate a lot of shader overhead. So if you go to the next slide. So one of the observations that you can do is an operator is actually a wrapper around hooks. So it's a way to facilitate the usage of the hooks capabilities in Airflow. And also, not all async hooks are exposed through operators. So if you want to use them, you're still bound to use a Python operator. So now we can go to the next slide. So what has changed in Airflow 3.2? So first of all, now you can just define async task methods as first citizen methods. So you don't need to first like define, if you would omit here the task decorator, for example, you could define an async def fetch all method, but then you will need to define a synchronous method that will run it through async io.run. So you don't have to do that boilerplate code anymore. You can just do it directly by decorating or by passing the async method to the Python operator. So now we can go to the next slide. So yes, it's not only just a syntactic sugar. Why not? Because in Airflow 2, it would have worked, what I just explained with the boilerplate code, but in Airflow 3, it doesn't work. Because now we have Task SDK, and due to that, everything goes to the comms decoder, which also have to offer support for the async part. Like, for example, hooks can try to resolve connections or variables, and those have now also to be done asynchronously. And that was not supported until now in Airflow 3.2. You will be able to also do it asynchronously. Also, the Python operator will automatically detect if the callable you pass to it will be synchronous or asynchronous. So now we can go to the next slide. So when should we use the deferred operator and when should we use an async operator? Deferred operator is when you have lots of waiting. For example, a sensor is also a kind of an operator that does that. When there are long waiting times, small payloads, then you should use a deferred operator. An async operator, you will use it when you want to do the multiplexing part, when you have lots of concurrent I/O calls, for example, like Vikram explained, like file transfers or REST API calls, which also use underneath pagination and return large payloads. That's when you would use an async operator instead. So now we can go to the next slide. So here you see a comparison matrix for the performance regarding SFTP file transfers. So on the left side, you are the ones that behave poorly, let's say, and on the right side, you have two examples that behave very fast. So the first one will be the naive solution that you could do is use the SFTP operator in combination with dynamic task mapping. If you have some 100 files, it would be fine. But if you have more than 10,000 files, then you will run into performance issues. You could also use the SFTP operator with the upcoming dynamic task iteration feature, but still that would perform poorly because you don't use the async capabilities. Then you could, of course, write it completely yourself from scratch in a Python operator and use the SFTP synchronous hook with a for loop, which would be better, but still perform poorly. And then on the right side, you could use, for example, the async Python operator with an SFTP client pool and a for loop so that you loop, for example, over 17,000 files to download them. That will behave very well, but you will need to write some code for it. Or you could opt for the latest option, and that is the async Python operator with the SFTP client pool, but let the dynamic task iteration handle the looping for you. So now I showed you a lot of different examples, those that behave well, those that behave poorly. And now I will show you the code that's behind it. So if now go to the next slide, we will first show you the solution that we would do already in Airflow, because that already exists a very long time. Or so what you could do is you define an SFTP operator, and then you expand it over the remote paths that you want to download, for example. That will work if you have like 100 files, no problem. That will work very well. But if you have lots of files, then it will start to perform poorly. So now we go to the second example. There you see it's exactly the same. We still use the SFTP operator. And instead of doing the expanding, we do the iteration. That will still perform badly. Why? Because the SFTP operator underneath will still use the synchronous hook. It doesn't support deferred operation. So you will still use the synchronous hook, which will still be slow. So if we go to the third example, voila. So here we use the async, the new async feature in Python. But as you see, there is a lot of code here. So let me explain a bit. So first we will define an SFTP client pool. So that's a pool that will handle the concurrent connections for you to improve performance. And then you will need to define an async method that handles the download per file. And as you can see, for the download file method, I have to use the tenacity retry annotation to handle the the failures in case of failures, because we cannot rely on the task retry functionality, because if we will do that, that would mean that if one download fails, we would have to re-download the whole batch again, which we don't want to. So we have to do it manually internally via the download file method. And then also we have to chunk the huge number of files and parts so that we can then create asynchronous tasks and start the downloads and wait until they are completed. So it's quite some complex code. It works, but it's a lot of code to write. So if we go to the last example, that's the one that will use the upcoming dynamic task iteration feature. You'll see that the code has already become less complex. Also, we can now rely on the retry mechanism that are offered by Airflow under the hood. So we don't need the tenacity decorator. We still use the pool. And there you could say, but it's weird because here you iterate over the files and you always define the client pool. Yes, but the client pool is a singleton and it will stay a singleton because with dynamic task iteration, the iteration happens within the same worker. So we don't spawn different processes, which means that it will always go to the same instance. So it works. And then, of course, we just need to open the file and read it. So here we don't need to care about defining the tenacity decorator, for example. We also don't need to care about chunking and awaiting that the task has completed. This is all done for you under the hood. Okay, so now we can go to the next slide. So now you will say, but wait a minute, you're talking about dynamic task mapping and dynamic task iteration. What's the difference? So dynamic task mapping is a feature that already exists from Airflow 2.8, I think, or even earlier. So what it does, it will expand an XCOM on an operator and do the looping for you. But that will be done using separated task instances. And this will all be handled by the scheduler for you, while dynamic task iteration will do the looping on the XCOM within one single task. So you don't spawn multiple tasks per iteration. So you can also see with the little illustrations below. On the left side, you have like 3 processes handling the file, and on the right side, you have like 3 threads processing a lot of file. So that's actually the difference. So now we can go to the next slide. Thank you. So there is a QR code to the AEP page that explains the Python async operator support that has been added in Airflow 3.2. And on the right side, we have the QR code of a Medium article I wrote and that Kexel also posted on LinkedIn, which describes the new dynamic task iteration feature more in depth. So thank you for listening. That's it.
Amazing presentation. Thank you so much, David. I'm so happy we got to hear that today. If anyone has any questions for David, please drop them in the chat. I'm sure he's open to chatting over Airflow Slack as well. You can find him there. Thank you so much. Yeah, and then Christos is going to be presenting his PR coming up. So Christos, whenever you're ready, I can drive or you can, whichever you prefer.
I think it's easier if I change the slides. Should I share the presentation? How is
Absolutely.
it going to work? Okay. Yeah. Just a minute. I think I shared the wrong screen. Okay. Okay, can you see?
Yes.
All right. Hi, I'm Christos Vicias. I'm a software engineer and I work at G-Research at the open source department. Thank you for voting my PR as PR of the month. So let's get started. At G-Research, in our production environment, we noticed that the schedulers and the workers were using at most 50% of their CPU capacity. And we repeatedly changed the configuration to optimize performance, but we didn't see any improvement. We started doing some investigation and we found out that each scheduler iteration was queuing a very small number of tasks or even none, although it had the resources and there were a lot of tasks waiting in the background, in the backlog. Uh, to explain the scheduler algorithm in a very high level overview, the scheduler picks tasks in FIFO order and based on priorities, it runs a database query that fetches scheduled tasks. It checks the available resources like the pool slots and then the diagram concurrency limits. It identifies which tasks are eligible to run and then moves them to the queued state. Now, the actual issue that we uncovered was that the database query was taking into consideration only the resources, the available pool slots, but it wasn't actually taking the concurrency limit max active tasks per DAG, which sets the number of active tasks that we can have active at the same time for a DAG run. Now, the concurrency limit was enforced only after the tasks had already been retrieved from the database. The result was that the throughput was very low because the query was concentrating on very high priority DAG runs, even if they had maxed out concurrency, and was fetching tasks from that DAG run to examine, but those tasks couldn't be queued because of the limit. So the scheduler was wasting iterations processing tasks that it couldn't run. We found out that if we include the max active tasks per DAG limit in the query, the scheduler does the calculations in advance as part of the query when deciding which tasks to fetch from the database and examine. And so the query ends up fetching from the database only tasks that it can actually be queued and doesn't waste any processing. So here's an example. If we have max active tasks per DAG set to 4, and we are examining a diagram that has 4 tasks which are already running, the old query would pick tasks from it, although it couldn't queue them and only show that down the iteration and the checking later, it would see that it cannot actually queue them and then it would drop them. But the new query will ignore that diagram entirely and will just move on to the next. And so for a diagram that has 2 tasks, which are already running and 2 that can be queued, then the new query will just pick 2 and move to the next diagram and pick tasks to examine from that one. So I'm gonna, in the next slides, I'm gonna share the results of a benchmark test. And so for the benchmark, I used 6 diagrams, 6 DAGs with 4,000 tasks in total. And as you can see, there were some DAGs that had a less number of tasks and another one that had 1,000 more. And so for the configuration, I set 100 tasks per iteration. So each query is going to examine up to 100 tasks if it has the resources. We can have 4 active tasks maximum for each diagram. And also I try to provide enough resources to avoid starvation by not having enough pool slots, by setting parallelism to 100 and the pool slot count to 64. So if we check these graphs, left we have the results from the new code, and right we have the results from the old code. The first graph, it shows the number of diagrams. It shows how many diagrams we are picking tasks from concurrently. The second graph, the one in the middle, it shows the number of task instances that we are currently queuing, and the third graph shows the number of task instances that we are examining. So in the first graph, we can see that it picked tasks from all 6 diagrams, where the old code was just concentrating in 2 diagrams, the highest priority ones. And now the other 2 graphs make more sense if we just compare them and we view them combined. So we were examining 20 tasks and we were queuing 15, while the old code was examining more than 60 only to be able to queue only 10. And if we can see in the timing from 3:30 and afterwards, it was examining 60 plus tasks only to queue 5. So we had we are not wasting any time examining tasks that we cannot process anymore, and the number of concurrent diagrams in this particular example, it was triple from the original code. Now, same idea as before. The left one is the new code and the right one is the old code. And here we can see in the first graph the total number of task instances, which is the same, around 4,000. And the graph on the bottom shows the total number of scheduler iterations. And so the new code was actually doing half the iterations, because each iteration it was doing more meaningful work and not wasting processing. So it was 50% less iterations for the same number of tasks. Now, there are some caveats for these benchmarks. The testing machine that I used had 20 core CPU and a 32 gigabyte RAM. And I found in other benchmarks that I took that the better the machine, the greater the throughput increase. And also, the changes in this patch, they provide the biggest difference, the greater performance improvement with the more load on the system. Now, I've run various tests, and when we don't have that much load, there isn't a difference, which is a good thing because it doesn't have neither negative nor positive impact where we don't have load, but it has a great impact when we have huge load on the system, which is exactly when we actually noticed all the issues with our schedulers and workers. You can check out my PR. There are a lot of tests and benchmarks there, different from this one. And thank you very much. If you have any questions.
Thank you so much, Christos, and congrats again on winning PR of the month. Well deserved. And if anyone has any questions for Christos, please drop them in the chat now and we can talk about it further. With that, I want to repeat myself from the top of the call. The Airflow Summit CFP closes on March 13th, and I know many of you like to wait till the week of, so I'm so excited to read all of the submissions that have yet to come in. So please, if you haven't submitted your talk to Airflow Summit, please do so as soon as possible. A reminder, it will be taking place in Austin, Texas, August 31st through September 2nd. It's a little bit earlier this year, hence the earlier CFP submission deadline. I've been getting some feedback that the deadline feels a little early this year and folks kind of don't know what they're going to want to present on at that time of year. What I would say to that is submit something anyway. And then if you want to make adjustments to your CFP later on, you can shoot me a note or any of the conference organizers, and we can kind of talk through how to make updates to your presentation. But I would definitely make sure to get those submissions in ASAP. And super early bird tickets are on sale. So this is the best time to buy the cheapest ticket to Airflow Summit. If you're going to ask for your company to cover it for you, this would be the best time to do that because it is the cheapest. It will also give you time to get those approvals in from your company. There's actually a section of the website if you look under attend on the Airflow Summit website, that says convince your boss. And it's kind of a email, letter, etc., that you can send to management, convincing them to cover your travel and accommodations to Airflow Summit. So I highly recommend checking that out and sending that note to management as soon as possible. There's no harm in asking, right, for your employer to cover your travel. It's easier to convince them if you're speaking as well. So definitely try and get that submission in as well. Really excited to have another successful Airflow Summit. And it'll be nice and warm this year at Airflow Summit, which I don't know if we've experienced in the past. So look forward to some awesome weather as well. And hopefully many of you can extend your trips into the weekend and really enjoy yourselves. So with that, I can end us a little bit early, with a couple of reminders. Make sure that you're in Airflow Slack if you're not already. Make sure that you join your local meetup group if you haven't already. If you're interested in starting one in your city, you can shoot me a note in Airflow Slack or via email. Um, One thing to note is we can only host Airflow meetups in cities where there is a decent sized concentration of Airflow users. So we cannot host them in every city, but we can certainly try. So I always encourage you to ask. Make sure you're subscribed to the Airflow monthly newsletter. It's sort of like an extended version of the town hall. So you'll see everything that happened in the previous month in the community. And that's a great way to stay up to date on where you can get involved, or if you're just more interested in just seeing what everyone else is doing. And then make sure you join the dev list. That's really the heart of the community. That's where folks like Vikram and David are kind of hashing out all the things that you're seeing them cover in this call. So if you want to get a little bit deeper, interested in becoming a committer, interested in contributing to the project, the dev list is a really, really good place to kind of monitor and see where you can dive in and get more involved. And I will drop all those links in the chat right now. Let me just pull them up. Do, do, do. Boom, links dropped. So yeah, I really appreciate you all joining me today and every month. And I hope to see many of you back next month because we have a great year ahead in the Airflow community and I'm really excited about it. So thanks everyone. Have a great weekend. For those of you whose evening it is, have a great Friday night. Those of you who are starting off your day, I'll see you in Slack, I guess. All right. Bye everyone.